Have you ever wondered how a machine can read a whole paragraph and actually get it? Like, really understand the point? Well, it all comes down to memory and context. Today, we're diving into the evolution of AI memory, from a really simple loop that, well, forgets things, to a brilliant system of smart gates that remembers. Okay, let's get into it. When we read, we're not just scanning a bunch of individual words. Our brains are constantly connecting them, building a bigger picture. But how on earth do you teach a computer to do that? How do we make it understand that the order of words changes absolutely everything? Just look at this sentence right here. If a machine only saw the word boring at the end, it would get the completely wrong idea, right? But the key is those two little words earlier, anything but. And that right there shows you, to really understand language, you have to remember what came before. The sequence is the whole game. So the folks building these systems knew they needed a model with some kind of memory. And their first big breakthrough was this really clever architecture called the Recurrent Neural Network, or the RNN for short. The big idea behind an RNN is, honestly, surprisingly simple. It's basically a neural network with a loop. As it processes each new word, it doesn't just look at that word in isolation. No, it also looks at a little summary of all the words it has seen before. And that summary, that's its memory. So how does this loop actually work in practice? Well, think of it like this. The network reads the very first word and creates a memory of it. Then, for the second word, it looks at that new word and the memory of the first one. It squishes them together into a new updated memory. It's almost like someone constantly whispering a running summary of the story into their own ear as they keep reading. Now, the RNN was a total game changer, for sure. But it had a fatal flaw. Its memory was pretty good for short stuff, but when you gave it longer sentences, it really started to struggle. It would just forget. Yeah, imagine you're reading a really long, dense paragraph. By the time you get to the end, the beginning might be a little fuzzy, right? Well, RNNs have an extreme version of exactly that problem. It's called the vanishing gradient problem. Basically, as that memory gets updated over and over, the information from the early words just gets watered down. For a long movie review, that crucial context from the first sentence could totally disappear by the time the network reaches the end. Its memory just isn't built for the long haul. So, to solve this very real memory problem, a much more sophisticated model was created. The Long Short-Term Memory Network, or LSTM. And believe me, this is where things get really, really cool. Okay, the difference between them is absolutely key. An RNN's memory is like a simple, continuous stream where all the new information just kind of mixes in with the old. But an LSTM, that's more like a managed reservoir, with a whole system of gates that actively control what information gets in and what gets out. These gates are the secret sauce. You can think of them like a tiny, super efficient librarian managing the AI's memory. You've got the forget gate, which looks at old information and decides, you know what, this isn't relevant anymore, let's get rid of it. Then there's the input gate, which looks at new info and says, ooh, this is important, we're definitely saving this. And finally, the output gate, which decides what part of the memory is needed for the task right now. It's a truly intelligent memory management system. So this fancy system sounds amazing in theory, but is it really that much better? Well, let's find out. It's time to put these models head-to-head in a classic challenge, analyzing thousands of real IMDb movie reviews to see if they're positive or negative. All right, in our showdown, we've got 4 competitors. First up, the classic RNN, the original memory loop model. Then we have the LSTM with its famous smart gates. And because researchers never stop tinkering, we've also got 2 other variations, the GRU, which is a simpler, faster version of the LSTM, and the bi-LSTM, which gets a huge advantage by reading the review both forwards and backwards to get the absolute full context. And the results are in. The basic RNN comes in at a respectable 82.3% accuracy. Not bad, but whoa. Look at that jump. The models with gates, the GRU and the LSTM, are way up there, neck and neck around 87%. And taking the top spot, the bi-LSTM, the one that reads in both directions, hits an incredible 88.2% accuracy. So the winner, by a clear margin, is the bidirectional LSTM.
Turns out, that ability to see a word in the context of what came before and what comes after makes all the difference in the world. This insight really says it all. That leap from the basic RNN to the LSTM gives us a massive 5% boost in accuracy. That is the power of those smart gates. They literally solve the problem of forgetting, which lets the model understand much longer, more complex sentences. So, what are the big lessons from this showdown? Well, first, context is king. The LSTM proved that reading a sentence both ways is a killer strategy. Second, those gate mechanisms in LSTMs, they are a monumental improvement, no question. And finally, the simpler GRU model shows us that sometimes you can get almost the same power, just with a more efficient engine. Now, this showdown is way more than just a fun academic exercise. The exact same ideas we just saw, the importance of gates, of context, of efficiency, are being used right now to solve some major real-world problems. I mean, think about it. That need to remember long-term context, that's absolutely crucial for analyzing long customer service calls to find hidden issues. That ability to spot patterns in a long sequence, that's used to sift through mountains of network logs to detect security threats. And predicting what comes next in a sequence, that helps companies figure out when a customer might be about to leave. And yeah, this stuff is literally powering the autocomplete and translation apps on your phone every single day. Ultimately, what this all really boils down to is this. By designing AI with better, more sophisticated memory, we give it the power to understand the sequences that define our world, everything from human language to customer behavior and even financial markets. And that brings us to a final thought. We've just seen how these models mastered language to understand sentiment. The next frontier is applying them to totally different kinds of sequences, like time series data, to try and predict things like stock prices. So as AI memory keeps getting better and better, what complex pattern is it going to help us understand next? And maybe more importantly,